Right, so MAFIS is a multiple actors forest information system that has basically two components, natural environment and the urban environment. Actually, we started with the natural environment, and then ESA has asked us, the European Space Agency has asked us to consider also the urban environment because of the importance of cities in our life today. Let's have a quick view to the MAFIS in the natural environment. Here we had two regions, Veneto and Tuscany, where we had two test sites. And we looked at the above ground biomass primarily, and also to some specific events that determined a large area destruction of trees. And for doing this, we have used mainly satellite data in the radar domain because of the capacity of L-band radar to penetrate the foliage and therefore extract information about trunks and big arms, so the major components of AGB. On the urban environment, we have involved a number of other players like nurseries, arborists, agronomists, architects and planners, and the customers have mainly been identified in the municipalities, of course. And the objective of this component is basically to find and demonstrate services in support of local planning and local management, especially to foster the improvement of the ecosystem services. Then let's have a look at the first results. Okay, and another step is about ESA asking us to implement MAFIS on the forestry tab, which is a thematic exploitation platform established already 3 years ago, and on the urban tab. So to take these information layers and merge them with the other activities and the other services offered by these two quite developed platforms. And in order to support the effort on the urban environment, ESA is putting at our disposal a network of resources, which basically means storage and computing resources, and also an environment for let's say enabling cooperation between the project partners, and also allowing the customers and the users to access the results of the project. So on the natural environment, we have combined, as I said, satellite data, artificial intelligence, and in situ surveys together with the growth model. And the information that we have provided is an accurate estimate of forest AGB, and more specifically about the AGB variations, both the growing of the stock and biomass losses, disturbances due to a number of events. Okay, and the third, to monitor also the clear cuts and the selective cutting that create big problems and are not properly monitored so far. This is an example of the AGB product, and here we have on the left August 2016, on the right June 2020, and of course if we do the delta, the addition, we have the growing stock in each area. As you can see, we have a very detailed spatial resolution. This is instead an example of the clear cuts, and clearly there is the possibility of improving the current accuracy of the perimetration of the burned areas. The cut areas and also the burned areas. But let's move into the urban domain, the urban environment. And just from the previous presentation, we have understood how important the trees are. Whether they are sufficient or not, it's difficult to judge. I think personally that green areas are probably more difficult to implement, as was said, but probably we can use planting trees to improve locally the situation. And trees are basically helping improving the urban resilience, are basically really a kind of natural infrastructure, and support both the ecosystem health and the biodiversity. And not only, let's say, from an environmental point of view, but also from an economic point of view, because urban areas with a lot of green and trees has much more value than other areas. And also from a touristic point of view, these green areas are nicer and attract more tourists. So there is also a direct economic return in supporting planting more trees. What is the project going to do? Basically, we have three basic steps. First step is updating of the urban green inventory and the classification of the main species. Here you see that it is not only possible to be done by in situ measurements in the public areas. This is Florence, and you see the yellow dots are the trees that have been sensed, whilst you see how much private green is available there, and any estimate or impact on the ecosystem services cannot neglect the impact of the private green. To do that, we integrate various types of data, aerial, in situ, and also very powerful satellite data, like very high resolution, down to 30 centimeters, hyperspectral, and also radar data. And of course, this would enable to be much more faster in maintaining an updated urban information system about the green areas. Second step is the estimate of the ecosystem services, and specialized model produced by the University of Florence will be used to monitor the tree health status. Here you see an area which is close to my house, and you see that a big course has been completely damaged by illness of trees, and there is a kind of something hurting me every time I pass over there. Carbon sequestration, then removal or reduction, let's say filtering of particulate pollution, assessment of the surface temperature and also the thermal comfort for people. And another topic that we will be tackling together with University of Molise is the interconnections between urban and peri-urban green areas. So these are important in order to enable animals to move back and forth, and so to keep the green areas in the city alive over time. And the phenological phase is also important in order to predict and support the measures for pollens and allergies. The third step is the monitoring and maintenance of the trees. So the regular monitoring of the trees, and I want to highlight that the availability of Sentinel-2 data allows really to take advantage of very long time series data. So we can reduce the errors by integrating something like maybe 20, 30 images, also comparing seasonal variation from one year to another year. And then the identification of specific targeted actions that needs to be taken. For example, simple tree cutting is something that we have found out that it's quite important, not only for possible danger to people, but also because they interact with the public lighting system and create dark areas that the citizens are complaining about. Okay, this is just to highlight a little bit the various partners and stakeholders that we have, and I would like to thank them all, because we learned already a lot from the left part of the project, the natural environment, where we worked with the GOK, which is Tor Vergata University spin-off, RDM Progetti from Florence, and University of Molise. We have national and the regional stakeholders, also international, like European Environmental Agency and Wood Chain European Associations, and CSEF, the Italian Silviculture and Forestry Association. On the right side, for the urban areas, we have the University of Florence. And actually we selected, because of them and the availability of local data, we have selected Florence as a kind of leader city for this development. Polytechnic of Milan, Super Alberi, which is a small company working really on intervening and on the trees, making the tree cutting and also detailed assessment of their health status, and University of Košice that will support the thermal comfort analysis. In terms of municipalities, we have, you see here, 8 of them, but we are increasing the number of interested cities, like Paris and Lisbon, and also Tirana is adding to the group. Of course, we have also the support from FAO. I'm finished, and I thank you for your attention. I would be available for answers to your questions.